A beam of light left Earth the moment you blinked. In 1 second, it could circle our planet 7 times. It seems instantaneous. It seems like nothing could possibly be faster. And that is exactly where the most terrifying trap of our existence lies. If we pull the camera back and look at our Milky Way galaxy in its entirety, this fast beam of light turns into a snail. It would take 4 years just to reach our nearest neighbor, the star Proxima Centauri. 4 years of silence and emptiness. And across the entire galaxy from edge to edge, it would take 100,000 years. Think about that. 100,000 years of flight at the maximum possible speed in the universe. We are used to looking at the stars and dreaming of travel. But physics tells us a brutal truth. We are not explorers. We are prisoners. We are trapped in a cosmic prison where the walls are made not of concrete, but of distance. And the bars of this cell are forged from light itself. Right now, somewhere in the void, the fastest object ever built by human hands is flying. The Parker Solar Probe. It screams through space at 190,000 miles per hour. That is insanely fast. At that speed, you could fly from New York to Tokyo in less than a minute. But on a cosmic scale, the Parker probe isn't even crawling. It is standing still. If we pointed this ship toward the nearest star, the journey would take 70,000 years. To help you understand the scale of this tragedy, 70,000 years ago on Earth, the last ice age was just beginning. Our ancestors were still painting on cave walls when this ship would have had to launch just to arrive at its destination today. Human life is too short even to simply knock on our neighbor's door. And it drives us mad. We see billions of stars. We know there are likely other worlds out there. We have built telescopes that can see the edge of the observable universe, but we are like a child with their nose pressed against the glass of a toy store. We can look, but we can never enter. Space isn't just big, it actively mocks our ambitions. Every star you see in the night sky is a mirage. You are seeing their past, not their present. And any signal we send there will take so long to travel that by the time an answer arrives, our civilization might no longer exist. The Voyagers, launched nearly 50 years ago, have barely left the gravitational backyard of the solar system. 50 years of flight, and they have traveled only 14 billion miles. On the scale of interstellar travel, that is the equivalent of stepping out of your house and taking one single step off the porch. We are stuck. And the problem isn't that our engines are too weak. The problem is much deeper. The very structure of reality seems to be rigged against us. We are trying to cross an ocean on a paper boat using rules invented for a sandbox. Chemical rockets, ion drives, even theoretical nuclear engines, they all work on one principle. And this principle has become our curse. This principle is simple to the point of absurdity. To move forward, you have to throw something backward. You push the ground with your feet, the ground pushes you. A rocket burns fuel and ejects superheated gas from a nozzle, and that gas pushes the rocket up. This is Newton's third law, and it is the hand choking the life out of us. Scientists call this the tyranny of the rocket equation, and that name is no exaggeration. It is a mathematical death sentence. Imagine you are going on a road trip, but your car has a strange feature. The more gas you put in the tank, the heavier the car becomes, and the harder it is for the engine to accelerate it. To drive 100 kilometers, you need 10 liters. But those 10 liters have weight. So, to carry that weight, you need to add another couple of liters on top. But those extra liters also have weight. And you need fuel to carry that fuel. On the scale of a trip to the moon, this is a solvable problem. That is why the Saturn V rocket was the size of a skyscraper, while the capsule with the astronauts was the size of a closet. 90% of a rocket is just a gas tank needed to lift that very same gas tank off the ground. But when we talk about the stars, this math turns into a nightmare. Let's say we want to accelerate a ship to just 10% of the speed of light. That is still painfully slow. A trip to the nearest star would take 40 years. But even for such a turtle's pace, using the best chemical fuel we have, we would need a fuel tank. How big? Imagine a ball of fuel the size of the entire observable universe. And even that wouldn't be enough to accelerate a single person to near-light speed on a standard rocket. Of course, we have ideas better than kerosene. Ion engines, nuclear reactors, even antimatter annihilation. They are more efficient. They eject matter at much higher speeds, but they don't cancel the law. They just push the wall we are crashing into a little further back. Even with a perfect fusion drive, to reach a speed where the journey becomes shorter than a human lifespan, your ship would have to consist almost entirely of fuel. It is a dead end. We are like islanders trying to build a raft out of logs to cross an ocean. We can pick lighter logs, we can tie them tighter, but the very concept of a raft is unsuited for the task. As long as we rely on reaction mass, we aren't going anywhere. Mars will remain our limit. Maybe the moons of Jupiter, but the stars? Never. To reach them, we need to stop playing by Newton's rules. We need to stop thinking about how to push off harder. We need to look at what exactly prevents us from accelerating infinitely. And here enters humanity's chief jailer, a man with messy hair who, in 1905, wrote an equation that forbade us from dreaming. Albert Einstein. We are used to thinking of him as a genius who opened our eyes to the structure of the universe. But for anyone dreaming of the stars, he is the strictest warden in history. His special theory of relativity placed a stop sign at the mark of 299,792,458 meters per second, the speed of light. And this isn't just a traffic rule you can break if there are no police around. It is a fundamental barrier of reality. The problem lies in his famous formula, E equals mc squared. Energy equals mass. We usually think of this as a way to get energy from an atom, like in a nuclear bomb. But this equation works in reverse too. Energy also has mass. When you accelerate a ship, you pump kinetic energy of motion into it. The faster you fly, the more energy you have. And that means the more you weigh. At the speeds of a car or a plane, this effect is negligible. But as you approach the speed of light, it becomes monstrous. Your ship starts to gain mass. You step on the gas harder, burn more fuel, but instead of acceleration, that energy just makes your ship heavier. It feels like a nightmare where you try to run, but your legs turn to lead. The moment you reach 99.9% of the speed of light, your small spaceship will weigh more than the entire planet Earth. And to reach exactly 100%, you would need infinite energy. There isn't enough energy in the entire universe to accelerate even a single atom with mass to the speed of light. Nature protects this limit with fanatical cruelty. It even begins to distort time itself, just so you don't exceed the speed. The faster you move, the slower the clock ticks for you. If you somehow manage to accelerate enough, you will return to Earth after a couple of years by your watch, only to find that millennia have passed on your home planet. Everyone you knew is long dead. Your cities have turned to dust. It is a one-way ticket to the future. But there is something even scarier. Why is the universe so afraid of faster-than-light speeds? Because the speed of light is actually the speed of causality. It is the speed at which a cause produces an effect. If you outrun light, you outrun the very logic of events. There is a paradox. If you move faster than light, to some observers you will appear to be moving backward in time. You could send a signal that arrives yesterday. You could fire a gun and hit the target before you pulled the trigger. You could return to the past and stop your parents from meeting. The universe bans FTL travel to protect itself from the breakdown of logic, to prevent reality from turning into chaos where the effect happens before the cause. It would seem the case is closed. Einstein double-locked the door, threw away the key, and poured concrete into the keyhole. Moving through space faster than light is physically impossible. But in that phrasing, there is one word we missed: through. Einstein said that nothing can move through space faster than light, but he never forbade space itself from doing whatever it wants. The year was 1994. A young Mexican physicist named Miguel Alcubierre was sitting in front of his TV, watching another episode of Star Trek. On the screen, the Starship Enterprise engaged its warp drive, the stars turned into streaks, and the heroes sped off faster than light. For most viewers, it was just a special effect. For Alcubierre, it was a challenge. He asked himself, is this actually possible without violating Einstein's equations? He took a pen and paper and started calculating, and what he found shocked the scientific world. It turned out Einstein hadn't slammed the door shut. He had left it ajar. Recall the example of an escalator in an airport. You can stand on the belt completely motionless. You aren't taking a single step, but relative to the building, you are moving forward. Alcubierre proposed doing the same thing, but with the fabric of the universe itself. The idea was to create a bubble. Imagine a spaceship surrounded by a sphere. A mechanism compresses space right in front of the ship's nose, literally shortening kilometers to centimeters. And simultaneously, it wildly expands space behind the ship. This creates a gravitational wave. The ship sits inside a flat, calm patch of space-time that rides this wave like a surfer. Inside this bubble, the ship isn't moving at all. The engines are off. You are floating in zero gravity. Your cup of coffee won't even ripple. Relative to the bubble itself, your speed is zero. And that means no infinite mass, no time dilation. You won't age and you won't kill your grandfather. Einstein's rules only work inside space, but space itself doesn't obey those rules. It can stretch and compress at any speed, even 1,000,000 times faster than light. And we know this for sure because it has already happened. In the first fractions of a second after the Big Bang, our universe went through a stage called inflation. Space expanded so fast that points which were next to each other flew apart at speeds many times exceeding the speed of light. Nature has already broken this ban. Alcubierre simply proposed repeating this trick locally around one small ship. The solution was elegant. It was beautiful. It was fully consistent with general relativity. Mathematically, the warp drive became reality. The blueprint of the Enterprise stopped being science fiction and became a scientific paper in a serious journal. Scientists rejoiced. It seemed we had found a way to trick the god of physics. We could compress stars to arm's reach. A trip to Alpha Centauri wouldn't take 4 years or 100,000 years, but say 2 weeks. But when the euphoria faded, physicists looked at Alcubierre's equation more closely, and they saw the price tag attached to this ticket. On paper, the drive worked perfectly, but to build it in the real world, an ingredient was required that might not even exist. And if it does exist, the amount needed would be simply astronomical. The entire problem lay in what the bubble needed to be built from. In Einstein's equations, there is an ironclad rule: gravity always attracts. Any matter we know, from hydrogen atoms to black holes, has positive mass and curves space inward. It's like putting a bowling ball on a trampoline. A pit forms. But to make the Alcubierre drive work, we need to do the opposite. We need not to attract space, but to push it away behind the ship. We need to create not a pit on the trampoline, but a hill. This requires a substance with negative mass. Physicists call this exotic matter. This isn't antimatter. Antimatter has positive mass, just a different charge. This is something that falls up, not down. If you pushed a ball of this matter, it wouldn't fly away from you, it would fly towards you. It sounds like the ravings of a madman, and perhaps it is. In the entire universe, we have never seen a single gram of such a substance. The only place we've seen a hint of such negative energy is the microscopic quantum Casimir effect occurring between 2 plates in a vacuum. But the scale of this effect is so negligible that using it for a starship is like trying to boil an ocean with a single match. But even if we found a way to create this matter, a second problem remained: quantity. When physicists first calculated how much energy was needed to create an Alcubierre bubble around a small ship, their calculators returned an error. The answer was more than exists in the entire observable universe. To start this engine, you would have to convert every star, every galaxy, and every speck of dust in space into pure energy. Later, the calculations were refined. Optimists said, "No, it's not that bad. We just need to completely annihilate a planet the size of Jupiter." Imagine this dialogue in the design bureau. "We built the engine, sir." "Excellent. What do we need to fuel it?" "Just destroy the biggest planet in the solar system, and we can visit the neighbors." It was a dead end. A beautiful mathematical fairy tale crashed against the harsh reality of energy consumption. Since 1994, for almost 30 years straight, the warp drive was considered impossible. Scientists wrote papers, defended dissertations, but at the end of every text was the same conclusion: requires negative energy, impossible. Humanity accepted it. We decided that the speed of light really was the final boss that couldn't be beaten. The warp drive took its place on the science fiction shelf, right next to time machines and teleporters. It seemed we would never take it down. But in 2021, at the height of the global pandemic, when everyone was stuck at home, an astrophysicist, bored in quarantine, decided to double-check the old equations. And he noticed a mistake that no one had seen for 30 years. Eric Lentz, a young astrophysicist from the University of Göttingen, did what we often forget to do. He looked at the problem from a different angle. All previous scientists tried to build a bubble of a specific shape, and this shape required negative energy. Lentz asked the question, are there other geometric shapes that can also move faster than light, but consist of ordinary matter? He dove into the wilds of so-called solitons, self-sustaining waves. And in 2021, he found a solution. It turned out that if you fold spacetime in a specific way, using a complex structure of plasma and electromagnetic fields, you can create a warp bubble using only positive energy. No more exotic matter. No magic dust that falls upward. You need ordinary energy. The same kind we have in our wall sockets, just in massive quantities. This changed everything. In 1 second, the warp drive went from a physical impossibility to a difficult engineering challenge. The impossible barrier collapsed. The expensive barrier remained. But even that barrier began to melt before our eyes. Following Lentz, other groups of scientists began optimizing the calculations. If before we needed the mass of Jupiter, new models showed if we make the bubble not spherical but flat like a pill, and make the ship fly not inside but sort of surfing on the edge, energy requirements drop by trillions of times. Today's calculations say that creating a small warp bubble might require energy comparable to the mass of a car, or, by other estimates, the power of a large nuclear reactor. That is still a lot, but it is no longer all the energy of the universe. It is something we know how to produce. And while theorists were breaking their heads over formulas, a practitioner named Harold "Sonny" White stumbled upon the Holy Grail by accident. Dr. White was working under contract with DARPA, the U.S. Agency for Advanced Defense Projects. He wasn't building a starship. He was studying microscopic structures for cooling electronics, so-called Casimir cavities. One day, while analyzing data on energy distribution inside these cavities, he noticed something strange. The graph on the monitor looked painfully familiar. White pulled up Alcubierre's old blueprints. He overlaid his real data onto the theoretical model of the warp drive. And they matched. At the nanometer scale, inside a laboratory, entirely by accident, a structure of energy distribution appeared that was mathematically a tiny warp bubble. It didn't move. There was no ship in it. It was smaller than a bacterium. But it was real. On that day, White proved that we can manipulate the fabric of space-time in a lab. We are no longer just drawing formulas on a chalkboard. We have started to touch the technology with our hands. Now the question isn't, is it possible? But how do we make it bigger? How do we scale this nano effect to the size of a ship? We stand on the threshold. A technology that seemed like magic is gaining blueprints. But as always happens in the history of science, when we open a new door, not only a miracle awaits us behind it, but also a new nightmare. Scientists modeling the warp drive flight discovered a side effect, and it is so terrifying that it might put an end to any contact with aliens. Imagine this historic moment. We built the ship, we found the energy, the crew took their seats, the captain gave the order, and space around them compressed. The ship vanished from the solar system, only to appear an instant later near a planet orbiting another star. It should be a moment of triumph. First contact. We open the airlocks to greet an alien civilization, but the answer will be dead silence and a scorched desert where, a second ago, cities bloomed. Physicists call this the shotgun effect. The thing is, outer space isn't entirely empty. It is filled with gas, dust, and free photons. When you fly inside a warp bubble faster than light, you don't just glide through them. You scoop them up in front of you. Your warp bubble works like a snowplow on a highway. Particles of matter and light accumulate on the front wall of the bubble. But since you are flying faster than light, this energy cannot disperse. It compresses, densifies, and heats up to monstrous levels. Inside the bubble, you are safe. But the moment you hit the brakes and turn off the engine, the bubble collapses. All that energy accumulated during the flight, that entire hellish cocktail of gamma radiation and high-energy particles, blasts forward in one concentrated beam, right into the face of the planet you arrived at. According to calculations by scientists at the University of Sydney, the arrival of even a small ship could release energy capable of sterilizing an entire planet. We will come in peace, but our very arrival will be equivalent to a strike from the Death Star. We will destroy those we wanted to find simply by hitting the brakes. This is an engineering problem. Perhaps we will learn to disperse this energy or exit warp far from the target. But there is a problem engineers cannot solve: the problem of time. In special relativity, speed, space, and time are tied in a knot that cannot be untied. If you draw space-time graphs, movement faster than light looks like instantaneous travel to some observers, and to others, like movement backward in time. This isn't science fiction, it's geometry. FTL flight is equivalent to a time machine. Imagine you are flying on such a ship. You could plot a course to return to Earth earlier than you left. You could land and shake hands with yourself getting into the rocket. This breaks causality. If you return and stop the ship from taking off, then who returned to stop it? The universe hates such paradoxes. Stephen Hawking proposed the chronology protection conjecture. He believed the laws of physics are designed to prevent time travel at any cost. What would this look like in practice? Perhaps every time we try to turn on the warp drive, it will explode. Quantum fluctuations will build up at the moment of launch, destroying the equipment. The universe will literally resist our desire to violate its order. We find ourselves in a strange situation. We found a loophole in the laws of physics. We lowered the energy requirements. We saw that it is possible. But perhaps the very structure of reality has placed a minefield here so that children don't play with matches. And yet, humanity has never known how to stop at a danger sign. We began this journey with a sense of claustrophobia. We felt locked in a tiny corner of an infinite universe, chained to Earth by the shackles of physical laws. But look at what has happened in just the last half hour of our story. We went from "this is impossible in principle" to "it's possible but needs the energy of the universe," and then to "needs the energy of Jupiter," and finally to "needs the energy of a nuclear reactor." The wall that seemed indestructible has cracked. In 1895, Lord Kelvin, president of the Royal Society, declared, "Heavier-than-air flying machines are impossible." 8 years later, the Wright brothers lifted off the ground. In 1920, the New York Times mocked rocket pioneer Robert Goddard for the idea that a rocket could work in a vacuum. They wrote that he lacked the knowledge ladled out daily in high schools. 49 years later, Apollo 11 landed on the moon. The history of science teaches us one thing. The word impossible is not a verdict. It is a challenge. It is simply a temporary placeholder we put on things we do not yet understand. Yes, mountains of problems still stand before us. We need to solve the radiation issues so we don't burn worlds upon landing. We need to figure out the time paradoxes. We need to build reactors of a power that currently exist only on blueprints. Perhaps we are the generation that will never see the stars with our own eyes. We are the ones laying the foundation. We are drawing the maps for the ships our grandchildren will build. But for the first time in human history, the stars have stopped being just pretty lights in the night sky. They have stopped being decoration. Now, looking up, we don't see an endless prison. We see a map. We see destinations. The cage door is open. The lock is broken. All that remains is to gather the courage to step into the dark and find out what awaits us there, beyond the threshold of light speed. And when that day comes, when the first ship dissolves into the shimmer of a warp bubble, humanity will finally grow up. We will cease to be a lonely species trapped on one planet. We will become citizens of the galaxy.